The Proteaceae are a family of flowering plants predominantly distributed in the Southern Hemisphere. The family comprises 83 genera with about 1,660 known species. Together with the Platanaceae and Nelumbonaceae, they make up the order Proteales. Well-known genera include Protea, Banksia, Embothrium, Grevillea, Hakea, Dryandra, and Macadamia. Species such as the New South Wales waratah, king Protea, and various species of Banksia, Grevillea, and Leucadendron are popular cut flowers, while the nuts of Macadamia integrifolia are widely grown commercially and consumed. Australia and South Africa have the greatest concentrations of diversity. Etymology. The name Proteaceae by Antoine Laurent de Jussieu in 1789 was based on the genus Protea, which in 1767 Carl Linnaeus derived from the name of the Greek god Proteus, a deity that was able to change between many forms. This is an appropriate image, seeing as the family is known for its astonishing variety and diversity of flowers and leaves. Description. Many genera of Proteaceae are highly variable, with Banksia in particular providing one of the most striking examples of adaptive radiation in plants. This variability makes it impossible to provide a simple, diagnostic identification key for the family. Although individual genera may be easily identified, Proteaceae are generally trees, rarely of more than 40 meters in height, and are usually of medium height or lower perennial shrubs. Except for some stylingia species that are herbs, they are facultatively deciduous, rarely acoalescent. The corline portion of the collar is often thickened. Indumentum of 3-celled hairs, sometimes glandular, rarely absent. The apical cell is usually elongated, acute, sometimes equally or unequally bifid. Leaves rarely aromatic, usually alternate, and in a spiral, rarely opposed, or verticillate. Coriaceous, rarely fleshy-as penestlant. Simple or compound, entire-edged to pinnatisect, rarely divided dichotomously, often remotely toothed, crenate or serrated, seated or stalked, the petiole frequently with a swollen base but rarely sheathed, without stipules, pinnate sometimes palmate to parallel venation, brachydodromous or reduced to a single prominent vein, venation normally conduplicate, anisophilia often occurs during the different growth periods. Leaf blade dorsiventral, isobilateral ascented, massifial tissue usually with sclerenchymatous idioblasts, rare secretory cavities. Brachyparasitic stomata. Plant stems with two types of radii, wide and multiserrated, and narrow and uniserrated, phloem stratified or not. Trilacunar nodes with 3 leaf traces, scleroids, frequent bark with lenticels, frequently horizontally enlarged, core cambium present, usually superficial. Roots lateral and short, often grouped in bundles with very dense root hairs, rarely with mycorrhiza. Plants usually hermaphroditic, more rarely monoecious, dioecious or andromonoecious. Inflorescence is very variable, simple or compound, axillary or terminal, lateral flowers solitary or in pairs, rarely with a terminal flower. Racemiform, paniculated condensed, usually with bracts, sometimes converted into leaves, or squamiform, forming a type of cone, or with bright colors, forming an involucre or pseudanthium. The peduncles and pedicels sometimes contracted, compacted with the rachis. In some cases the congested inflorescences form superinflorescences. Very rarely the flowers are solitary and axillary near the end of branches. In species with lignotubes the flowers sometimes grow from these and pass through the soil. Flowers are usually perfect, actinomorphic, or zygomorphic, hypogynous, frequently large and showy. flat or oblique, sometimes forming a gynophore, hypogynous disc present and extrastaminal or abstinent. Perianthophore tepals in one-valvate whorls, sometimes elongated in a basal sac, free or fused in different ways, or even connivant by marginally interdigitate papillae forming a tube or a bilabiate structure, zygomorphic, sometimes opening laterally in a variety of ways. Haplostaminous androecium, usually isostaminous, opposition tepilis of 4 stamens, all fertile, some converted into staminodes, usually filamentous. Filaments partially or totally fused to the tepals, rarely free. Base-affixed anthers adnate to the tetrasporangiate, sometimes unilocular and bisphoragiate. Intraostelatros, expanded connective, usually with apiculus, dehiscence along longitudinal tiers. Hypogynous glands 1 to 4, squamiform or elongated, fleshy, free or fused, forming a lunate or annular nectary over the receptacle. Superior gynoecium of 1 apocarpus, carpels, sessile stipitate, sometimes not completely closed, style usually developed. Stigma small or in the shape of a terminal or subterminal disc or even lateral and oblique, often indented. Papillus, moist to dry. Ovules 1 to 100 or more per carpel. Anatropous, hemianatropous, amphitropous or orthotropous, mostly hemitropous. Bitegmic, crassinusilate. Chalaza with a ring of vascular bundles. The funiculus is occasionally absent and the ovule is fused to the placenta. Marginal placentation with various dispositions or apical. Fruit dehiscent or indehiscent. Inachena nucule. Follicle, drupa, falsely drupal, sometimes similar to a Acaropsis as it is fused to the wall of the ovary and the testa, often lignified and serotinous. The fruit from the same inflorescence are sometimes fused, forming a syncarp. Seeds 1 many, sometimes winged, flat-rounded, with endosperm absent, present in Belendina. Endotesta with an unusual layer containing crystals of calcium oxalate that is rarely absent. Well-differentiated embryo, straight dicotyledonous, but often with 3 or more large cotyledons, often auriculate. Pollen in monads, triangular in polar view, 3 apiturate, usually isopolar and triparate, biparate in Embothrium and the Banksia tribe. Colpoidate in Boprea, spherical in Orlax and Franklandia, are strongly anisopolar in some species of Petunia. The openings of the former's tetrads follow Garcide's law. Chromosomal number n equals 5, 7, 10 to 14, 26, 28. Sizes range from very small to very big according to species. X equals 7, 12. Flowers. Generally speaking, the diagnostic feature of Proteaceae is the compound flowerhead, or, more accurately, inflorescence. In many genera, the most obvious feature is the large and often very showy inflorescences, consisting of many small flowers densely packed into a compact head or spike. Even this character, however, does not occur in all Proteaceae. Adenanthus species, for example, have solitary flowers. In most Proteaceae species, the pollination mechanism is highly specialized. It usually involves the use of a pollen presenter, an area on the style end that presents the pollen to the pollinator. Proteaceae flower parts occur in 4s, but the 4 tepals are fused into a long, narrow tube with a closed cup at the top, and the filaments of the 4 stamens are fused to the tepals in such a way that the anthers are enclosed within the cup. The pistil initially passes along the inside of the perianth tube, so the stigma, too, is enclosed within the cup. As the flower develops, the pistil grows rapidly. Since the stigma is trapped, the style must bend to elongate, and eventually it bends so far it splits the perianth along one seam. The style continues to grow until anthosis, when the nectaries begin to produce nectar. At this time, the perianth splits into its component tepals, the cup splits apart, and the pistil is released to spring more or less upright. Ecology. Many of the Proteaceae have specialized proteoid roots, masses of lateral roots and hairs forming a radial absorptive surface, produced in the leaf-litter layer during seasonal growth, and usually shriveling at the end of the growth season. They are an adaptation to growth in poor, phosphorus-deficient soils, greatly increasing the plant's access to scarce water and nutrients by exuding carboxylates that mobilize previously unavailable phosphorus. They also increase the root's absorption surface, but this is a minor feature, as it also increases competition for nutrients against its own root clusters. However, this adaptation leaves them highly vulnerable to dieback caused by the Phytophthora cinnamomum water mole, and generally intolerant of fertilization. Due to these specialized proteoid roots, the Proteaceae are one of few flowering plant families that do not form symbioses with arbuscular mycorrhizal fungi. They exude large amounts of organic acids every 2 to 3 days in order to aid the mobilization and absorption of phosphate. Many species are fire-adapted, meaning they have strategies for surviving fires that sweep through the habitat. Some are resprouters, and have a thick rootstock buried in the ground that shoots up new stems after a fire, and others are reseeders, meaning the adult plants are killed by the fire, but disperse the seeds, which are stimulated by the smoke to take root and grow. The heat was previously thought to have stimulated growth, but the chemicals in the smoke have now been shown to cause it. There are 4 dioecious genera, 11 andromonoecious genera, and some other genera have species that are cryptically andromonoecious. 2 species are sterile and only reproduce vegetatively. The species vary between being autocompatible and auto-incompatible. With intermediate situations, these situations sometimes occur in the same species. The flowers are usually protandrous. Just before anthosis, the anthers release the pollen, depositing it onto the stigma, which in many cases has an enlarged fleshy area specifically for the deposition of its own pollen. Nectar feeders are unlikely to come into contact with the anthers themselves, but can hardly avoid contacting the stigma. Thus, the stigma functions as a pollen presenter, ensuring the nectar feeders act as pollinators. The downside of this pollination strategy is that the probability of self-fertilization is greatly increased. Many Proteaceae counter this with strategies such as protandry, self-incompatibility, or preferential abortion of self seed. The systems for presenting pollen are usually highly diverse, corresponding to the diversification of the pollinators. Pollination is carried out by bees, beetles, flies, moths, birds, and mammals are highly lignified and resistant to fire. The fruit only release the seeds when they have been burnt and when the ground has been fertilized with ashes from the fire and is free from competitors. Many species have seeds with eliosomes that are dispersed by ants. The seeds with wings of thistledown exhibit anemicary, while the drupes and other fleshy fruit exhibit endozoochry as mammals and birds ingest them. Some African and Australian rodents are known to accumulate fruit and seeds of these plants in the nests in order to feed on them, although some manage to germinate. Distribution. Proteaceae are mainly a Southern Hemisphere family, with its main centers of diversity in Australia and South Africa. It also occurs in Central Africa, South and Central America, India, Eastern and Southeastern Asia, and Oceania. Only 2 species are known from New Zealand, although fossil pollen evidence suggests there were more previously. It is a good example of a Gondwanan family, with taxa occurring occurring on virtually every landmass considered a remnant of the ancient supercontinent Gondwana, except Antarctica. The family and subfamilies are thought to have diversified well before the fragmentation of Gondwana, implying all of them are well over 90 million years old. Evidence for this includes an abundance of Proteaceous pollen found in the Cretaceous coal deposits of the South Island of New Zealand. It is thought to have achieved its present distribution largely by continental drift rather than dispersal across ocean gaps. Phytochemistry. No conclusive studies have been carried out on the chemical substances present in this broad family. The genera Protea and Phorea are unusual as they use xylose as the main sugar in the nectar and as they have high concentrations of polygylactol, while sucrose is the main sugar present in Grevillea. Cyanogenic glycosides derived from tyrosine are often present, as are proanthocyanidins, flavonols and arbutin. Alkaloids are usually absent. Iridoids and ellagic acid are also absent. Saponins and sapogenins can be either present or absent in different species. Many species accumulate aluminium. Uses and cultivation. Many indigenous cultures have used Proteaceae as sustenance medicine for curing animal hides, as a source of dyes, firewood and as wood for construction. Aboriginal Australians eat the fruit of Petunia and the seeds of species from other genera, including Grevillea and Macadamia, form part of the diet not only of the indigenous peoples but they are also sold throughout the world. The tender shoots of Helicia species are used in Java and the nectar from the inflorescences of a number of species is drunk in Australia. Traditional medicines can be obtained from infusions of the roots, bark, leaves or flowers of many species that are used as topical applications for skin conditions or internally as tonics, aphrodisiacs, galactogens, to treat headaches, cough, dysentery, diarrhea, indigestion, stomach ulcers and kidney disease. The wood from the trees of this family are widely used in construction and for internal uses such as decoration. The wood from species of Protea, Leucadendron and Grevillea are especially popular. Many species are used in gardening, particularly genera of Banksia, Embothrium, Grevillea and Tilapia. Unfortunately, this use has resulted in the introduction of exotic species that have become invasive. Examples of this include the Hakea willow and the silky Hakea in Portugal. Two species of Macadamia are cultivated commercially for their edible nuts. Grevillea avellana is cultivated for its edible nuts in Chile and New Zealand, and they are also used in the pharmaceutical industry for the humectant properties and as an ingredient in sunscreens. It is the most resistant to cold of the tree families that produce nuts. It is also planted in the British Isles and on the Pacific coast of the United States for its tropical appearance and its ability to grow in cooler climates. Many Proteaceae species are cultivated by the nursery industry as barrier plants and for their prominent and distinctive flowers and foliage. Some species are of importance to the cut flower industry, especially some Banksia and Protea species. Two species of the genus Macadamia are grown commercially for edible nuts. Grevillea avellana tree is cultivated for its nuts in Chile and New Zealand, which are edible, and are used in pharmaceutical industry for skin treatment because of the moisturizing properties and as ingredient in sunscreens. Sugar bushes, pincushions and cone bushes, as well as others like pagodas, orlacs and blushing brides, comprise one of the three main plant groups of fynbos, which forms part of the Cape floral kingdom, the smallest but richest plant kingdom for its size and the only kingdom contained within a single country. The other main groups of plants in fynbos are the Ericaceae and the Restricinaceae. South African Protea Proteas are thus widely cultivated due to the many varied forms and unusual flowers. They are popular in South Africa for the beauty and the usefulness in wildlife gardens for attracting birds and useful insects. The species most valued as ornamentals of the trees that grow in southern latitudes, as they give landscapes in temperate climates a tropical appearance. Lomatia ferruginea, Lomatia hirsute have been introduced in Western Europe and to the western United States. Embothrium coccinea is highly valued in the British Isles for its dark red flowers, and it can be found as far north as the Faroe Islands at a latitude of 62 degrees north. Among the Banksias, many of which grow in temperate and Mediterranean climates, the vast majority are shrubs. Only a few are trees that are valued for the height. Among the tallest species are B. integrifolia with its subspecies B. integrifolia subsp. monticola, which is noteworthy as the plants that form the subspecies of the tallest trees of the Banksias, and they are the more frost-resistant than other Banksias. B. seminuda, B. literalis, B. serrata. Among those that can be considered small trees are large shrubs B. grandis, B. prionotes, B. marginata, B. coccinea and B. speciosa. All of these are planted in parks and gardens and even along roadsides because of the size. The rest of the species of this genus, around 170 species, are shrubs, although some of them are valued for the flowers. Another species that is cultivated in some parts of the world, although it is smaller, is Tilapia speciosissima, for the mountains of New South Wales, Australia. Some temperate climate species are cultivated more locally in Australia for their attractive appearance. Petunia pinifolia is highly valued for its vivid yellow flowers and grape-like fruit. Adenanthus ericaeus is planted for its attractive soft leaves and its small red or orange flowers. Hickspecie pinnatifolia is commonly planted for its foliage and edible nuts. Parasites. The Proteaceae are particularly susceptible to certain parasites, in particular the omycete Phytophthora cinnamomum, which causes severe root rot in the plants that grow in Mediterranean climates. Fusarium oxysphorum causes a disease called fusariosis in roots that causes a yellowing and wilting, with serious ecological damages to woodland plants and economic losses in plants of commercial interest. Other common infections are caused by species of Botrysopharia, Rhizoctonia, Armillaria, Botrytis calinectria and other fungi. Conservation status. The IUCN considers that 47 Proteaceae species are threatened, of which one species, Stenocarpus dumensis wyoming, 1935, from New Caledonia, is thought to be extinct. The species of this family are particularly susceptible to the destruction or fragmentation of the habitat, fire, parasitic diseases, competition from introduced plants, soil degradation and other damage provoked by humans and the domesticated animals. The species are also affected by climate change. Fossils. The Proteaceae have a rich fossil record, despite the inherent difficulties in identifying remains that do not show diagnostic characteristics. Identification usually comes from using a combination of brachyparasitic stomata and the unusual trichome bases, or, in other cases, the unusual structure of pollen tetrads. Fossils attributable to this family have been found on the majority of areas that formed the Gondwana supercontinent. A wide variety of pollen belonging to this family dating back to the Upper Cretaceous from the southeast of Australia and pollen from the Middle Cretaceous from northern Africa and Peru described as Triorites africensis. The first microfossils appear 20 million years later in the Paleocene of South America and the northeast of Australia. The fossil record of some areas, such as New Zealand and Tasmania, show a greater biodiversity for Proteaceae than currently exists, which supports the fact that the distribution of many taxa has changed drastically with the passage of time and that the family has suffered a general decline, including high levels of extinction during the Cenozoic. Taxonomy, first described by French botanist Antoine Laurent de Jussieu, the Proteaceae family is a fairly large one, with around 80 genera, but less than 2,000 species. It is recognized by virtually all taxonomists, firmly established under classical Linnean taxonomy. It is also recognized by the cladistics-based APG and APG2 systems. It is placed in the order Proteales, whose placement has itself varied. The framework for classification of the genera within Proteaceae was laid by Laurie Johnson and Barbara Briggs in their influential 1975 monograph on the Proteaceae, the evolution and classification of a southern family. The classification has been refined somewhat over the ensuing 3 decades, most notably by Peter H. Weston and Nigel Barker in 2006. Proteaceae are now divided into 5 subfamilies: Belladonnoideae, Personioideae, Symphonematoideae, Proteoideae and Grevilleoideae. In 2008, Mast and colleagues updated Macadamia and related genera in tribe Macadamiae. Furthermore, Orytes megacarpus was found as polyphyletic with a not in the Orytes genus, nor in the tribe Proteaceae, instead in the tribe Macadamiae also, hence given the new genus Nothrites and species name combination of Nothrites megacarpus. The full arrangement, according to Weston and Barker with the updates to genera from Mast et al., is as follows.